Hello again, everyone. Mr. Cruze here with another Algebra 2 review for you. This time, the semester final exam review, part 3. In this video, we're just going to continue chugging through some problems, alright? If at any time you have questions, you can always tweet me, email me, leave a comment on this video, or come in for extra help, alright? I want you to do well on this, so please use all your resources, alright? I want you to do well in this class, okay? 24, solve the equation, check our answers. Well, you could always check your answers. I'm not going to, okay? But believe me, they do work, all right? Just for the sake of this video and time, all right? This is log of 3x plus 1 equals 2, okay? Whenever you don't have a base, it's base 10, right? So I'm going to do what I call bumping the base, okay? We're going to bump that base. Basically, the 10 and the log kind of cancel each other out, and you're left with 3x plus 1 equals 10 squared, okay? Obviously, whatever you do to one side, you must do to the other. So we bumped that base, okay? 10 squared is obviously 100. And then it's just an Algebra 1 equation. 3x equals 99, which means x equals 33. Again, you can always plug these answers back into your original equation and make sure that they work, okay? 25, kind of similar. The only rule about the bumping the base thing is I can't do it until the log is by itself. So I've got to get rid of that pesky 3 out front. Okay, but that's easy. Log of 3x equals 1/2, right? 1.5 divided by 3 is 1/2, because it's half of it. Again, bump that base. Well, the base is 10 again, because they didn't write it. So we have 3x equals 10 to the 0.5 power. Won't be the prettiest number in the world. Let's see, roughly 3.162. And then you finally divide that by 3 to win the day. All right. You should get something like 1.054. Again, these are all approximate because we're rounding, right? Lots of rounding with logs sometimes, but that's all right. 26, suppose that x and y vary inversely. Inverse. That was the y equals k over x thing. We did this a while ago, okay? But basically, if I rearrange this, that means x times y equals k. I just multiplied both sides by x, right? So basically, they want us to write a function. This is almost a function. The only thing is I need k, right? So that's where this comes in handy, right? xy equals k. Because they give me an x, and they give me a y. So that means k equals 1.2 times 3. And that'll be 3.6. So that means y equals 3.6 over x. That's a function. Okay? So basically now if I were to give you any value of x, you could find y and vice versa. Right? So we've got it. Find the vertical asymptotes and holes for the graph of the rational function. Okay. Basically, you remember these next few are all about these rational expressions and functions, right? Your goal is to factor them completely, first off, so you have to remember how to factor, okay? And then you also have to remember that you can't have certain x values. There are restrictions, okay? Basically, we can't divide by 0. So what number would make x minus 2 equal 0? Well, how about 2? So x can't equal 2, because if I plug it in, the denominator becomes 0, and we can't divide by 0, the world explodes, bad things happen. Same thing happens if I plug in x equals -1, so x can't equal either of those numbers. Now we just have to determine are those vertical asymptotes or holes. If they cancel out, meaning things are the same, if they cancel, doesn't it kind of leave like an empty space in the problem? Kind of like a hole is an empty space. So that means the one that gives us x can't equal 2 is a hole. Okay? X equals 2 is a hole. The one that doesn't cancel out, the x plus 1, that'll be equals. That'll be a vertical asymptote. Okay? Think of it kind of like jail bars. It doesn't go away. Okay? As much as you want it to. Since it didn't cancel out, it's a vertical asymptote. Okay? 28, what's the rational expression in simplest form? Okay, this one we've kind of got a factor, so let's start with the top. I need two numbers that multiply to -8 and add to 2. Well, how about a +4 and a -2? Check it if you don't believe me. Multiplies to a -8, adds to a +4. On the bottom, multiplies to 6 and adds to -5. Well, how about a -2 and a +3? Okay? Now, Since it says stating restrictions, I like to list the restrictions before we cancel. That way I know I can do so legally. So let's look at the denominator. X can't equal 2, and it can't equal -3, because if I plug in either of those numbers, bad things happen. Now I can feel free to cancel anything that's the same on the top and the bottom. I'm going to make sure that cancels all the way through. So we're left with x plus 4 over x plus 3. And hopefully you remember, you can't just like cancel these x's, right? They don't just go away. They're still there. X plus 4 is a different number than x plus 3, so you can't cancel. 29, ooh, division of fractions. Okay, so we're going to have to remember a couple things here. First off, let's go ahead and factor what we can. Okay, so what multiplies to 4 and adds to 5? Well, that'll be 4 and 1, right? On the bottom, what multiplies to -12 and adds to +1? Well, how about a +4 and a -3? That'll work. Divided by x squared minus 1 factors into x minus 1, x plus 1. That's a difference of squares. You can basically think about it the same way we did these two. What multiplies to -1 and adds to 0? There is no middle term. Well, that'd be +1 and -1. And on the bottom, the only thing you can do here is pull out a GCF, a greatest common factor, which would be 2x. Okay? It's at this point we can go ahead and start looking at what x can't be. Can't be from over here, it can't be -4. From over here, it can't be +3. From here, 2x is a little tricky, but what number, if I plugged it in there, would make this 0? Well, it'd be 0. 2 times 0 is 0, right? And this one is +3, but we already have that listed, okay? But remember, this is division now, right? So when you divide fractions, you have to remember my little trick, KFC. K means keep the first fraction, okay? So we're going to basically keep this first fraction as it is, okay? Flip means, F means flip, flip the second fraction. So anything that was on bottom now becomes on top, and vice versa. And change means change the problem to multiplication. So I'm going to get rid of this now because we don't need it anymore. And then we'll move this into position. Now, we KFC'd. But here's an issue that just popped up. Now, since we flipped the fraction, these are now on bottom as well, okay? So with division, you have to keep this in mind because now these are in the denominator, which means they can't equal 0 either. So x also can't equal 1 or -1. There's actually 5 restrictions total. With division, just remember you have to check the top and the bottom of the second fraction, all right? Now we can feel free to cancel now that we've listed our restrictions. So anything that's the same on top and bottom cancels out. We have an x plus 1 over here. We have an x minus 3. Those go away. The only thing we're left with is 2x over x minus 1, as long as x does not equal -4, 3, 0, 1, or -1. Okay. 30 is multiplication. Multiplying is not so bad. I like to go ahead and multiply them together first. So let's do numbers. 4 times 7 is 28. X squared times y is just x squared y. Over 5 times 12 is 60, x to the 4th y. Okay, now we can reduce. By the way, take a look at the denominator. X and y, neither one of them can equal 0, because if they do, our denominator becomes 0, and that is a bad thing, right? Let's reduce it. 28 and 60, I believe 4 goes into both of those, right? 7 over 15. Yeah, that looks right. X squared and x to the 4th, how do they cancel? Well, there's 2 x's on the top, technically, and 4 in the bottom. So that means 2 of them are going to cancel, leaving you 2 on the bottom. And both of the y's are going to cancel because there's only 1 in the top and the bottom. So we actually get 7 over 15x squared, as long as x and y aren't 0. Okay. 31 is subtraction. Do you remember how to subtract fractions? I hope you do, because you have to get common denominators. So let's go ahead and completely factor everything first. X plus 2 over, this will factor into x times x minus 2, minus, let's see, the bottom over here will factor into 2 times x minus 2. Look at their denominators. Okay, what do they have in common? Well, currently they both have an x minus 2, so that's looking good in our favor. However, this one over here has an x, which means I need to multiply this side by an x to get that x. But if I do something to the bottom, I have to do it to the top as well, otherwise things are different. Now, let's look at this denominator compared to this one. This one has an extra 2, so I have to multiply by 2 over 2. Okay? And then you just have to remember how to distribute. 2 times x will be 2x. 2 times 2 is 4. Over, and you can actually just go ahead and leave the denominator factored. That'll be alright. Okay? Minus, this will now be x squared plus 2x, because I distributed the x's. Okay? And if you saw the last video, you remember I had to be careful about these minus signs. I changed it to plus and then add the opposite, right? So anyway, we end up with negative x. I'm going to rearrange this. Negative x squared. This 2x and this negative 2x cancel each other out. So we're just left with a positive 4 over 2x times x minus 2. And you might think we're done, okay? Oh, by the way, we should probably state restrictions while we're thinking about it. X can't equal 0 or 2, right? And I think it's the only thing that's on the bottom. Yep. So there's our restrictions while we're thinking about it. I'm going to go ahead and erase all this work that we did here, okay? The adding part. And you might think we're done. This is our answer, but it's actually not. If I pull out a negative 1 up top, we get x squared minus 4. And if you recall, x squared minus 4 is actually x minus 2 times x plus 2. And hey, look, we have an x minus 2 in the top and the bottom that cancel out. So you actually have negative 1 over x plus 2 divided by 2x. That one was a little tricky. You just have to be on the lookout for what can possibly factor. All right. 32, add, state any restrictions on the variable. Once again, you need common denominators, all right? So we've got negative 3x over, how does x squared minus 9 factor? Well, it factors into x minus 3 and x plus 3. Plus 4 over, I pull out a 2 and I'm left with x minus 3 over here, all right? Once again, just take a look at the denominators. What are they missing? This one over here seems to be missing a 2, so I'm going to multiply by 2 over 2. This one seems to be missing an x plus 3, so I'm going to have to multiply by, I'm running out of room over here. I'm going to have to multiply by x plus 3 on the top and the bottom, okay? So let's see. 2 times negative 3x is negative, is that not working? Negative 6x over our common denominator plus, distribute the 4 to the x plus 3, so you get 4x plus 12 over the common denominator. And then now you can just feel free to add the tops, okay? Negative 6x plus 4x gives you negative 2x plus 12 over your common denominator, all right? By the way, let's look at the denominator and see what can x not be. Well, it can't equal 3 or negative 3. Technically, it can still equal 0 because there's no problem with plugging in 0, okay? By the way, you could factor out the negative 2 up top. You'd be left with x minus 6, which will not cancel with any of these down here, okay? All right, I think we're going to call it a video because we're almost out of time. So, in the next video, we will continue chugging on through, all right? See you guys then.